Hi, this is Tairan Wang, and now I'm going to give the presentation about the AI behavior tree. It's the creative phase of the AI phase, and my tutorial is based upon the chapter 4 of the book, Behavior Selection Algorithms, Several Methods of Behavior Selection, and it includes the behavior tree method. And the tutorial is here. If you are interested, please check the book. And I have included another online tutorial in YouTube done by a game develop chef. It's pretty great. If you are interested in, just please check it. And first, I'm gonna show uh, the demo tutorial from the video. Actually, this is the environment. Actually, we can see as the player moves far away from the enemy will try to chase the player. And as it's close enough, the enemy will shoot the player. And as the player is far enough, it will just stay right there. If it approaches into the range, it will just chase the player by the AI. And if it's close enough, it will be into a shoot pattern. And actually, the green one, it shows its shooting status. The different color shows different status. The yellow one's chasing. The red one is just staying. And if I just click the enemy a few times, okay, if we make it, it will just dodge. It will just escape from the player and find a safe place to cover. Actually, it's healing. And actually, as it's finished shooting, it should go out and just we can see if we try to approach it, it will just try to hide in another place to cover. That is the AI of the tutorial. The whole system is like that. The behavior tree will choose which node, which behavior to run. The whole system is like that. Firstly, there's a top node. It will choose the behavior of which one to run. Includes cover, shoot, and chase. And each one there are child nodes to help judge the node. And for example, the cover node includes a health node and a try to take cover node. As this one returns success, it will run this one, the try to take cover node, and for example, and then it will be judged in this pattern one by one. If this one is available, it runs this one, and if this one is available, and yeah, actually, if this one is available, it will run this one, and this one is available. Actually, this is a selector, and if this one is not available, it will run this one. There are differences between the selector and sequence, which I will introduce later. This includes different functions as their nodes, and for each node, it includes the fields, the public enum, the node state, includes the potential states of each node, success, failure, and running. The methods includes a node state evaluate method that will be used for evaluating the status. And for each selector and sequence, it will include a list of nodes, the list nodes for evaluation of the pattern, the status. And as for the selector, it will check each child until find the one with the success node. If one is success, the whole node returns success. If all are failure, then the whole node returns failure. Then this whole node won't be working. And the sequence is check all nodes to see if all of them are success. If one is failure, then the whole node returns failure. If one returns success, the whole will return success. Okay, now I'm gonna show my demo. My demo is pretty simple, just a simple object, and it will find a way to go. And if it detects the barrier, it will just rotate to find the way to go. Well, this happens maybe because the collision issue, this one has been exited, but this one hasn't been on. Okay, that is pretty my demo. And now I'm gonna introduce the behavior tree. So mine includes this system includes a top selector, turn sequence returns true if the child node are success, and a has barrier check if there's an obstacle in front of the AI, and there's a rotate pattern. It will return running if this one works. Rotate the object, and the running is similar to this one. It's just a movement. And now I'm going to introduce the scripts. For the first one, we have a node script. Actually, it's the most upper class of this system. It's a abstract class node, and we want to set the node state here, and we have the status running success failure set here, and then the function, abstract function evaluate, it will return each status of the node, and we have selector and sequence. The selector runs it will check its child nodes. Actually, they have a list of child nodes. If the for the selector, if one is running, it will return running. One is success, then the whole selector just returns success. If one is failure, it just check another node in this list, and if all of them are failure, then this one is failure. Yeah, and for the sequence, it will check firstly if it's running, it will mark, and if it's a success, it will check the next one until all of them are success. If one is failure, then the whole one will be failure. Then it will choose between running and success. And if it's success, then all of them are success, it will return success. And actually, here are the three behaviors I've added. The behavior nodes all include a AI as the parameter, as a index, and those are the related fields that's needed for each function. For the we will set these fields from the AI script, and finally we still have the evaluate to check if it meets some requirement, the condition. Like the has barrier node, it will check if there's any barrier detected. If true, it returns success, then it returns failure. And for the turn and run node, it automatically running by the selector, so it will just return running. Those are the functions, the rotate and the movement. And finally, it's the AI script that will synthesize all of the nodes together and form a system. For example, we will add all of the related nodes, related fields first. Those are the fields that we needed for the player for the system. And then, except from static references, we will construct the behavior tree to form the system of the nodes. We will set up new nodes one by one. Like the Hasbro node, we will set this one. And for each of them, we will set the fields for each direction for each node here. Then we set the sequence and the selector. For the sequence, we will set a new sequence, added a list, the barrel node, and internal into the sequence. And finally, we will build the top selector, including the list sequence and the run node. Actually, it's a private field for this class because we will run it later. So we will run the update class, update function here. Then the whole system works, and those are some related judgment or evaluation criteria for each function. Well, that is my presentation. Thank you for listening.